sensor is powered by another battery.
Hi, I'm Jonae Coleman-Brigham, a Senior Research Fellow at the Minnesota Design Center in the College of Design at the University of Minnesota.
And I'm Paul Imbertson, a retired teaching professor in electrical and computer engineering in the College of Science and Engineering, Twin Cities.
And for 5 years, we co-led a very unusual class at the University of Minnesota called Power Systems Journey, making the invisible, visible, and actionable.
In this short video, we'll share a few highlights from the class and some thoughts on why an art-led interdisciplinary project-based class like this is important to prepare students for a changing energy future.
The idea for the class, which is part of the University of Minnesota's Grand Challenge curriculum, came from a conversation.
I wanted to add more art-based learning methods to my energy and power system courses.
And I wanted to take my Earth Systems Journey curriculum model, which is art-led environmental education, that I had used with water systems and apply it to the power system.
The University of Minnesota's Grand Challenge curriculum brings an interdisciplinary project-based approach to engaging students in addressing the world's complex problems. So it was the perfect setting to explore how the electric grid is part of the energy transition that is essential to address climate justice.
Since the class was based on my Earth Systems Journey model, it was organized as a hero's journey, integrating art and creative projects along the way. The hero's journey uses the natural learning form of stories to make sense of complex systems, in this case, electric infrastructure. By traveling upstream and downstream from a point of use, and the art and creative projects help make the experience more meaningful and personal. The ultimate goal of an Earth Systems Journey is to provide an experiential sense of interconnection with the world around us.
Along the journey, we asked students to sketch what they saw and make notes. Engineers used to sketch more, and it is good for anyone trying to really understand the world around them. We might notice the grid, but we don't really see it until we look closely, and sketching is a way to do that. We see more details when we sketch than when we snap a photo.
The visual learning was also reinforced through the creation of GIS story maps by student teams to publish online for a public audience. The goal was to improve public understanding of the electric grid as part of the energy transition. These can be intimidating topics, so the communication had to be compelling. GIS story maps were a great tool for creative storytelling as students integrated historic images, their own sketches and illustrations, and video into a cohesive web experience. Story maps are particularly suited to integrate interactive GIS maps to help make sense of the electric grid, which extends throughout our landscapes and spans the continent.
50 students were the protagonists of the journey, seeking interdisciplinary understanding to help face the grand challenges ahead. About half the students were in electrical engineering, and the other half came from all different fields, from biology to architecture to business.
A grad student studying environmental policy, Carl Knetsch, who later became a guest instructor, said he appreciated the interdisciplinary approach.
Once upon a time, I studied biology as an undergrad here at the U. I also studied environmental policy as a graduate student. So I'm someone who's very interested in the politics of climate change, or US politics in general, and the energy transition in general. Also someone who's a lover of art and things like movies and music and books. And I like to think about ways in which fictional stories can impact the ways in which we think about the world. So one thing that I always appreciated about the Power Systems Journey class was its emphasis on interdisciplinary thinking and creative thinking. And it's about understanding how the electric grid isn't just a dull, lifeless machine, but rather it's a very vibrant thing that is connected to many different aspects of our lives and of our society, and it physically connects everything together via communication or infrastructure a political dimension, an economic dimension, social dimension, geographical dimensions, and so much more. Obviously, there is a large technical and engineering dimension to the grid and to the energy transition, which our next generation of engineering students will work on and will attend to going forward. But what I really wanted to get across is just that all these other dimensions as well are also very important beyond just math and science and engineering.
We both believe that it is important to know how and why the grid was created the way that it was, so that we can understand the grid of the future.
We decided to focus on Minnesota and laid out the class in two parts: Minnesota Power Histories and Minnesota Power Futures.
Of course, there is the technical understanding of the grid from an engineering point of view, but we both felt that it was equally important to understand the values and policies that shaped the way it was designed and the ways in which it was perceived.
In the first half of the class, we read about the history of the grid alongside our journey, using Gretchen Baki's book, The Grid, with other shorter articles and videos to bring in many perspectives. Paul told the long history of energy in society, how the history of energy is really the history of our need for heat, light, and work.
Then I shared a token of our hero's journey, a bit of amber, which the Greeks called electrod. It induced static electricity when rubbed on cloth. This was part of the poetics of the course that made the journey more meaningful. Students kept the stone with them throughout the journey as a way to bind us together as a traveling group.
Next, in the history of energy, we toured Gibbs Farm, a museum that interprets early Dakota and pioneer life before the time of electricity.
The guide showed us how early residents of this area provided for their energy needs for heat, light, and work.
Then, across the street from Gibbs Farm, we began our journey from a light fixture in the Bell Museum that shone on a giant woolly mammoth in the Ice Age exhibit. The woolly mammoth became our mascot, linking us to deep history, back to the Pleistocene, when the climate was not as hospitable as it is now. This set the stage to consider how human actions on the planet are acting on this huge timescale, shifting the climate again.
From the light that shone on the mammoth, we traveled upstream to sample the many kinds of power plants that generate electricity. The grid is vast and our travel time was short, so we tried to choose a variety of types of power plants that were near the Twin Cities.
Both of us are fascinated by the electric grid. I love to photograph it and really get a sense of what historian David Nye calls the technological sublime. The first year we taught the class, it was in spring, which meant our tours began with snow on the ground. And I remember the pleasure we had as students got to experience this awe at the scale of energy infrastructure, made even more stark in the winter landscape.
One of those students on our first grid journey was Amethyst O'Connell, who was an electrical engineering student and then became a teaching assistant for several years after that before graduating and working as an electrical designer.
I draw systems, electrical systems for buildings so that other people can understand and build them. I think for the energy transition, we really should work on making the invisible visible, making those engineering systems that we've worked so hard to put in the background, give them the spotlight yet again and say, hey, these are here, you rely on them every day. They have a spot in your life. How do you want them to be in the future? We went and we saw a wind turbine and we walked up to the base of this wind turbine. And I remember, from the edge of the street, it was like, okay, yeah, that's a wind turbine. But as you get closer and closer and closer to this wind turbine until you're standing at the base of it, you realize, the power of engineering and the power of humanity and the power of the wind, really.
Another electric generating plant we went to that wowed the students with its scale was the Allen S. King coal-fired power plant.
Over the 5 years we taught the course, Allen S. King was part of the real-time energy transition as Xcel developed plans for its reduced operation as a coal plant with closing scheduled for 2028, and now reimagining it as a clean energy power plant.
The energy transition trend toward reduced environmental impacts was also a living story as students toured the university's main energy plant.
The main energy plant was a major project by the University of Minnesota to replace the old power plant with a new system of combined heat and power that harvests the waste heat from generating electricity and uses it in the steam heating system for Minneapolis campus. It is part of how the university is working towards its climate plan and sustainability goals.
Shane Stennis is the Chief Sustainability Officer for the University of Minnesota system. He works across all the University of Minnesota's 5 campuses and other operations around the state to lead strategic initiatives and programs around the goal to build a fully sustainable future.
Living laboratory is a concept that some higher education institutions have deployed to sort of reflect that their campuses can be part of the learning experience for students, and that the transformation or the study of or the experience of the campus can be integral to their educational experience. And so the University of Minnesota has taken a living lab approach on several of our campuses for the past decade and a half. And have tried to make campus spaces and locations available as a subject of study, as a place to do applied research and demonstration, and to really envision the campus environment as something that's not just a place in which you sort of pass through or experience in a passive way, but rather is part of the active learning experience, that it is in fact the subject of learning and subject of research.
At the other end of the scale, one year we visited an example of power generation at the residential scale, a solar rooftop at the Ohm Suite Ohm, a design by Sala Architects that showcases a clean, all-electric lifestyle.
These are just some of the locations that we visited, either in person or virtually. After understanding how power is generated, we follow the transmission lines to the terminal substation and its distribution lines that serve the Bell Museum and its neighborhood. From there, we followed the distribution lines through the electric meter and back to the light fixture above the woolly mammoth where we started.
But what is downstream of the light fixture? Does the grid stop there? No. The energy continues as we trace the light as it bounced off of the mammoth exhibit into our eyes to become vision and perception made possible by the electric grid. It is our use of electricity, our desire for light, heat, and work that drives the whole endeavor. We too are the grid.
This was a turning point in our journey of the electric grid and its history. We celebrated this milestone with a student symposium where the project teams shared their GIS story maps that shed light on Minnesota power history and would be published online.
Then Paul shared a second token, this time a piece of jet made of lignite coal, a memento of the past. Coal is integral with the history of power, and we can be grateful for all that it has done for society. But now it is time to move forward.
The second half of the class was focused on Minnesota power futures, and students once again created story maps to highlight interesting activities in the ongoing energy transition.
In this half of the class, students met leading energy thinkers from the field that made the challenges and solutions to the energy transition come alive as they shared their unique perspectives.
Each one has a different perspective on the energy transition. For this video, we asked them to reflect on different themes from the class.
Masoud Amin is the Chairman, President, and Chief Executive Officer of Energy Policy and Security Associates. He was a professor of electrical and computer engineering and served as the Honeywell H.W. Sweat Chair in Technological Leadership and the director of the Technological Leadership Institute. He is widely credited as being the father of smart grids and a cyber physical security leader.
Infrastructure defines progress. From Edison's Pearl Street Station in 1882 to today's smart AI-driven grids, power systems are the foundation of economic growth, environmental security, and stability. However, centralization creates efficiency, but also comes with risks. The US grid was centralized in a transition from 1907 to 1950s, but blackouts in 1965, 2003, and what we have seen in Texas in 2021 and other outages expose single points of failure that cascade throughout the system. Combining that backbone of centralized with the decentralization through microgrids, storage, smart systems optimization, AI-driven automation is key to our future resilience, job creation, and training. Energy transition is critical because I have mapped these, I've assessed them since data that I've obtained from 1950s to the present. We used to have 3 to 5 major outages a year caused by climate, by bad weather, back in the 50s, 60s, 70s, and 80s. In mid-1995, something happened. It started creeping up to the point that it creeped up to about 70 outages per year by 2010, 2012. Last year, we had over 130 outages caused by climate, aging infrastructure, and the impacts of extreme weather. These events by 2050 are highly likely to triple in frequency, even become more adverse, more extreme. The two extremes are expanding, coldest and hottest, requiring climate resilient, climate adaptive grid designs. So the future grid must be self-healing, smart, adaptive, cyber secure, and climate resilient.
Aaron Hansen is an energy program specialist for the Learning and Development Department at the Institute on the Environment on the University of Minnesota Twin Cities campus.
We also help coordinate interdisciplinary research projects. So research being the other side of a large research institution like the University of Minnesota, we have faculty looking into environmental sustainability from all sorts of different aspects. And something to be considered is how these different disciplines or areas of expertise can help inform other areas of expertise. So for example, working on the energy transition system and thinking about solar farms, the large utility scale solar farms that take up acres of land at a time, there's a lot of other environmental aspects to consider, such as what is the soil health and quality underneath those solar farms? Are there opportunities for ecological restoration or benefits such as planting pollinator habitat? And what are the water quality implications? We know that farming can have impacts to our public drinking water systems. So we have brought together teams of experts from all of these different environmental disciplines to think about the holistic nature of how solar farms interact with our landscapes. So between educational programming and research projects, that kind of gives you a flavor of the interdisciplinary nature of the work that we do here at the Institute on the Environment.
Robert Blake is the Executive Director of Native Son Community Power Development and owner of Solar Bear, and also a tribal citizen of the Red Lake Nation. He is a recognized leader in tribal energy sovereignty and solar workforce development.
I wonder if you could speak a little bit to the tribal energy sovereignty movement and what should people know about that movement?
I think the tribal energy sovereignty movement and the progress of it, and in my involvement, it really has been exciting because hearing from folks that are in this and that are wanting to get involved, they realize the connection to the culture and what it means to take care of the planet and the environment. it's just something that they're born with. It's their right. It's their birthright. They were given this. I always like to say that to the students and to the kids, and when I talk to them, and I see their eyes, and their eyes kind of light up, and I just hope they understand that they have a purpose and they have a reason for being here, being involved in this space and doing this work. They can make a great living, make a good living, and still at the same time, do something positive for the community and for the planet and the world around us. And I just think that kind of recognition of knowing that you're part of something bigger than yourself, and this is a part of your cultural teachings. I just think it resonates so much in Native people, and that's what really excites me about the energy sovereignty movement.
Catherine Millam is a professor of anthropology at the University of Minnesota Duluth. She is also an affiliate faculty member at the Minnesota Law School and at the Minnesota Design Center on the Twin Cities campus. She is the founder of a research initiative called the Solar Commons Project.
As an anthropologist, my work has for decades been involved with how people share things. And another way to call that is the commons. And so how do you share things that belong to everybody at a local scale, a water hole in a village that's shared, or a forest, or at a global scale? How do you share the high seas that belong to everyone? And how do you share a climate system that belongs to everyone? So as technologies change, human societies have had to rethink the territories, the regions, the domains in which they're trying to share things and create different structures for that sharing. That branch of anthropology, plus this idea of commons, how would commons tools, commons governance structures be used with solar? That's how I've been working. So the Solar Commons Project is a way to share the benefits, the financial benefits of solar energy. So you create solar savings on an electric bill, and those solar savings that are really, after you've calculated, benchmarked, and everything else, you can tell which of those solar savings are just pure free gifts from the sun, real commonwealth. And once you know that, you could create a dashboard to transparently show that this really is all free stuff. And that free stuff then can be shared. It can be, or it could be, if the solar's on the electric grid, you could have policy that says 1/10 of the grid's solar needs to be shared as Commonwealth.
Michael Noble is semi-retired, consulting through Noble Ideas, LLC, with clients in the private sector and in philanthropy and government. He is a long-time clean energy and environmental advocate in the nonprofit space. For nearly 30 years, he was the CEO of Fresh Energy and worked on the electricity system, transportation, the built environment, and industrial and agricultural decarbonization.
How might the energy transition reimagine our electric generation, distribution, use, ownership, and everything else about our energy systems to achieve our goals?
Well, you ask about our electricity system, the generation and the transmission, the distribution. I really think that is the very, very centerpiece of climate strategy and decarbonization. In my career, Fresh Energy and in public policy and energy policy over 30 years, toward the end of my tenure, I just realized that there were two main goals, and all the other goals were subordinate to that. And one was that we have to get all the carbon out of our electricity supply. And two was that we have to electrify everything that we practically can. So electrify everything we can and get all the carbon out of electricity is like 1-2 for decarbonization.
What do you want people to know about the energy transition?
I want people to know that it's fun, and the energy transition is going to be a ball. It's going to be super interesting. There's opportunities for every kind of career and every kind of professional person, whether
they have a degree in science or engineering or public policy or law or social services, or any degree, any credential, anything that people are bringing professionally to this world can plug into the energy transition. The energy system is the foundation of all human prosperity. Nothing happens without energy. Nothing in society and nothing in commerce, nothing in economic development happens without being fueled by energy. So if we're changing everything in energy, it's an extremely interesting place to put your mark down.
By the end of the class, the students had grounded themselves in electric power history and been inspired from mentors about hopeful electric power futures. They shared their explorations and GIS story maps in a final symposium.
Then Paul shared one last token to close out the journey. Another different type of amber, similar to the first gemstone, but with a new understanding of the story from ancient Greece.
Amber is formed from the sap of trees. Today we connect amber with the story of electricity because of how it behaves, making static electricity visible. But the ancient Greek word for amber, electron, is actually about the story of where it comes from. In their mythology, the sun god Helios had two daughters who had been turned into trees, and their tears formed amber. To the Greeks, amber, or electron, meant streaming sunlight.
And we are still trying to make sense of our stories of electricity. It matters what it is and what it does, but it also matters where it comes from. As we look back on 5 years of teaching this course together, we gained a lot of understanding and explored a lot of different perspectives. But a single course can't solve the grand challenge of the energy transition and climate justice for all.
Of course, a single course cannot solve a grand challenge, but it can instill capabilities and interest and drive in our students that they will use throughout their entire career to address these grand challenges.
We're grateful for our partners and students that made this all possible.
We couldn't have done it without them. They are what this course was all about, working together in a community.